All right, so starting with that first block, these are ones where you've got i's in the bottom. You've got to get rid of them by multiplying by the conjugate. So for 15, I multiply by 5 plus I, 16, 4 minus 3i. And then you want to FOIL out the numerators, combine what you can, replace your I squares with negative ones. And then for 15, you got 13 plus 13i over 26. Those are all divisible by 13, so it should be 1 plus I over 13. You don't have to split it into 2. You can, but you don't have to split it into 2 as long as it's simplified. Yeah. Oh, over 2. Yep, thank you. Over 2. I even just said it and had written it wrong. Over 2. Okay, and again, they could be split. You don't need to, though. For 16, you're multiplying by 4 minus 3i in the numerator. You want to, again, FOIL it out. Replace that I squared with a negative 1, making the 9 negative. 7 minus 24i all over that shortcut gives you the 16 plus a 9, which is 25. Sure. For 26, 27, and 28, remember you want to take the I out first. So for 26, we take out I, and I get I root 5 times I root 15, which is I squared times. Now, I know I'm going to break down that 15 anyway, so I keep them separate as 5 times 15. That breaks down to 3 and 5. The 5 repeats, so I bring that to the outside. I squared becomes negative 1. So it's negative 5 root 3. 27, I can take I out, making it a positive 70 over positive 7. And both of them are underneath the root, so I can simplify that to root 10. And then an I in the top and the bottom cancel out. 28, take the I out from underneath the root negative 40. Simplify it. 20 goes into itself once and 40 twice, and I get I square root 2. Questions on those? 32, take out the I. Simplify square root 50 to 5 root 2, and then 5 is divisible by, or 5 goes into all 3 of those, making it 1 plus I root 2 over 2. Don't forget the 1, like people tend to cancel through the 5 and it go completely away. That's not right. It's got to be 1. And then the last one, so the negative exponent brings it to the bottom. And then I want to rewrite it in terms of I squared. So I divide by 2, so I squared raised to the 51st power. And then I squared becomes negative 1, and negative 1 raised to an odd power stays negative. So I'd get 1 over negative 1, which is just negative 1. 32?
Are those always going to be negative 1?
No, if there's an even amount when you cut it in half, now it's positive 1.
So even is positive.
Once you cut it in half. So like if it's I negative 104, that's 1 over I squared raised to the 52nd, right? Which becomes 1 over negative 1 raised to the 52nd. That's an even number of negatives, which means it goes back positive. Right? Like if I had two negative ones, it goes positive. So if there's an even amount of negatives being multiplied together, it's going to go to positive. If there was an odd amount, it would stay negative.
When you split.
Once you divide it by 2, right? Because you got to put it in terms of I squared. I squared is what is negative 1. It's on the review too.
What is odd?
So if it's odd, we take out an I. So if it was I to the, let's say 53, I would rewrite as I 52 times I to the first, because that would give me back, right? Then I rewrite I squared, that would be to the 26th, right? Even number of negative ones means this becomes positive 1 times I would be just I. It's either going, unless there's another number attached to it, it's either going to be 1, negative 1, I, or negative I. So if it's even to begin with, it becomes 1 or negative 1. If it's odd to begin with, an I is going to be part of your answer. But then you got to cut it in half. If when you cut it in half, it stays even, now it's positive. You cut it in half, it goes odd, now it's negative. So there's only 4 outcomes. Like unless there's a number, like if it said 5I to the negative 104, this would be 5 over 1, which is 5. So, but if it's just the I by itself, it's going to be one of those 4 outcomes. You got a 1 in 4 shot. Yeah. Richard, you had a question? Huh? I explained it? Okay. Go me. All right. These are the 3 methods that we talked about yesterday. We add into this the 4th method, which was factoring. Okay, that's what's going to be added onto your test. So this has solve using square roots, solve by completing the square, and then solve using the quadratic formula. So I'm going to start with the square roots, okay? If I square root both sides of this equation, first of all, I can only have the x minus 4 squared on one side, so if there was something else, I'd move it. But then I square root and I get x minus 4 equals plus and minus the square root of negative 40, which becomes plus and minus I root 40, and that's 4 and 10. The 4 breaks down to 2 and 2. So I get plus and minus 2I root 10, x minus 4 equals. And then I just add the 4, and I get x equals 4 plus and minus 2I root 10. The other way to do that would be to expand and FOIL x minus 4 times x minus 4, get everything on one side, see if it's factorable, which it wouldn't have been, or use quadratic formula. Or you're glutton for punishment and you do complete square.
Would it be okay if you put plus or minus 2i times squared times plus 4?
Plus 4 is fine. Yeah. As long as the right sign is on the number, that's all. Yeah. Kevin.
What do you think, what's more on the test? Is it completing the square or quadratic formula?
It's an even split. I think there's forced 2, I think, of each of those. 2 factoring, 2 square roots, forced. The rest, there's somewhere you could choose.
Okay.
Yeah.
I think there's number 1 where you have to do it with completing square.
Like it's written in squared format and you have to do complete the square? No. No. You don't have to work it from one format to the other. Yeah.
Can you do one where we have to use factoring?
Yeah, so on the review, I'm going to open that next. You'll see there's factoring. There's all of it. It's kind of grouped together on the review. Yeah. So complete the square, right? The goal here is to get only the x squared and the x by itself. So I'm going to move the 1 to the other side. I'd get x squared minus 4x equals negative 6. Then I'm going to take that second number, the 4 in this case, divide it by 2 and square it. Now on the review, they're not even because they're not going to be even on your test. Okay, so just prepare yourself. And if there was a number on the front, I would have to divide everything by that number first. Okay, so these numbers get messy, I'll warn you, on your test, but it's the same process. So I would take the 4, divide it by 2, square it. That's 2 squared, which is 4. I add it here and I add it here. And then I have put this in perfect squared trinomial format. So square root, sign from the middle, put in the parentheses and square it, and I get negative 2. Now I square root both sides, putting the plus and the minus in front of the negative 2, and I get x minus 2 equals I, plus and minus, I square root 2, and then add the 2. So again, I will warn you that the one on the test gets messier than that because you're dealing with your fractions, which there's some on the test on the review to practice.
But if there's a number in front of the x squared, would you divide first before you move?
I move the constant to the other side and then divide. Because if you leave the 1 there, you have to divide the 1 by it and the negative 5 by it, and then you might have to combine and get a like denominator. That's yucky. So, but I would move the constant to the other side and then do it. All right, then quadratic formula. So my A is 1. No, sorry, my A is 8. Let me move this over first. X. 60. My A is 8, my B is 6, and C is 5. So negative B plus and minus the square root of B squared minus 4 times A times C all over 2 times A. I get negative 6 plus and minus the square root of 36. That's 20 times 8 minus 160 over 16. Negative 6 plus and minus the square root of negative 124 over 16. Break that down, so bring the I out. And this would be 2 and 62, 2 and 31. So I get negative 6 plus and minus 2I square root 31 over 16. And then those are all divisible by 2. 8, 3, 1. So negative 3 plus and minus I root 31 all over 8. And you don't have to separate it. You could leave it together. Questions? All right, so if you look, let me make sure. So this is chunked by like the grouping of it. So solve by factoring, solve by completing the squares, solve using square root, and then just solve for x. So it's kind of actually in, like this was 1.2, this was 1.4a, 1.4a, 1 point, actually that's a lie because they're rational, right? 1.4b. You can cross through this one. And then these come back, these came back in 1.5b's notes. Okay. And then the only other thing that's right is done on here is the quadratic formula. Yeah. The solving for x came first. So like numbers, number 4, A and B. Remember, you have special cases in there, right? Like your no solution if it cancels out and the left side doesn't equal the right side. And your all real numbers, okay? So remember those special cases. No solution, all real numbers. Those should be pretty straightforward. Just be careful with a negative that gets distributed. Like that's where silly mistake gets made, okay? So there's going to be parentheses. You're going to distribute. You're going to combine your like terms. If everything cancels and it's a true statement, it's all real numbers. If everything cancels and it's a false statement, it's no solution. Then came the solving by factoring. So be prepared for greatest common factor. You want to look for that first. You want to look for difference of 2 squares. All of that's going to be in there of 2 squares. If there's a trinomial where the a is not equal to 1, where you have to do the first and last. And your factor by grouping. So all the different types of factoring are built in there. The goal is to get everything to one side. These are already set with the goal, like with it equal to 0, but if they're not, you're going to move it. And then see which of those you can do to factor. Always check greatest common factor first, and then factor whichever method you need to use. Then came completing the square, and this, again, like I said, they're going to get messy. Like B is not that far off, okay? You might have a fraction on there that you need to, and you can't get rid of it by multiplying by 4 because then it brings the number back in the front, so you can't do it that way. You could do that, like if you were doing quadratic formula and you saw a fraction, you can get rid of it. But not when you're completing the square. Then solve using the square roots. You're square rooting both sides, making sure if there's a negative, obviously we take out the I. The bottom here, the perfect cubes are what we finished with yesterday, okay, where you have to factor the perfect cube. You're going to set the first parentheses equal to 0, and then the second parenthesis, you're going to have to do the quadratic formula. So those are the last two examples from yesterday. This one? The solutions are worked out and posted with this one too. So check as you go, but don't give yourself that false sense of he'll be checking before you do it. Yeah. Mm-hmm. And then this was 1.5a. No, yeah. Which was part of 1.4 B and 1.5 B. So if we go in order, And then all the i's, right? So we're rationalizing here. By multiplying by the conjugate of the denominator. And then you're multiplying, making sure you replace I squareds. And then like F, G, H was just like the example that we worked on the warm-up thing. All right, tell me what you need.
So what would be the conjugate? Can you explain that again?
What, the conjugate?
Where it's not, where there's no like addition and subtraction sign.
Oh, so like if, I mean, you won't see it, but let's say it just said like 3i, the conjugate is negative 3i. If it said 2, the conjugate is actually still just 2, because this would be plus 0i, and there's no such thing as minus 0i. It would just go away. Yeah, if it was negative 3i, then the conjugate's positive 3i. But you won't see it like that. You'll see it built into the rationalizing.
We're gonna have like really big numbers, like yesterday that we had like 7,000.
Like how big? How big do you consider really big?
Like more than 11.
No.
100.
When you're multiplying out underneath the square root, or like in general, like you're not going to see something huge in like your original problem, but you might have to do something where you factor it out. Yeah.
You can't make a calculator, right?
You cannot use a calculator. Your brain is your calculator.
Can you spell that?
Yeah. Like where? Like over here? Or to the last page?
Like 1 through 4.
All right, so if I'm doing this using square roots, the parentheses has to be on the side by itself, right? So I got to get rid of the 3/2 or the 2/3. I can either multiply both sides by 3/2, or I can do it in parts. I can multiply by a 3 and then divide by 2.
I just did minus by
3/2? Okay. So it cancels completely from here. I get 2x plus 3 squared equals, the 2 goes in the 18 9 times. 9 times 3 is negative 27. Then I want to square root both sides. I want to put that plus and minus in front on the right. And I get 2x plus 3 equals plus and minus. The I is going to come out. And then also this breaks down to 3 and 9 and 3 and 3. So you can bring a 3 out. So 3i, the 3 stays underneath. Then I'm going to subtract the 3. So I can get 2x equals negative 3 plus and minus 3i root 3. And then I want to divide by 2. And then the same number does not divide evenly into all of it, so you keep it like that.
Also, another question.
Mm-hmm.
When it was like x plus 1 equals like that, you always think that it's minus 1 or convert to a fraction. If there's one or like.
Oh, like if there's a whole number separate, I would take either answer. Kevin.
You could divide both sides of the thing by 2/3, right?
Yes. Yeah, it's the same thing. Yeah. Other questions? Yeah.
Did you do E for number 3?
Is this complete the square? Yeah. Okay. Good practice. I was just going to say I need to do one that's complete the square that's not. Oh, even this one divides in evenly. Try to find one that's messier than this. Okay, so I'm going to bump the 5 to the other side. Then I'm going to divide everything by 3. Then I take that second term, which on tomorrow's test will not be even. So keep in mind. 2 divided by 2, square it. 1 squared. 1, add it here and add it here. So I factor the left, x plus 1 squared equals, this becomes 3/3. So negative 2/3. Oh, this is good for the factoring. I mean the rationalization though. Then I square root it. I do the plus and minus. I get x plus 1 equals plus and minus I square root 2 over square root 3, which it can't stay like that. So we rationalize by multiplying by square root 3 in the top and the bottom. So it's plus and minus. This would be square root 6. So I square root 6 over root 3 times root 3, which is just 3. And then you can subtract the 1. So if you had moved the 1 first and combined them together like in a fraction, you would have to rationalize after. It gets messier. I would rationalize before and then just subtract the 1 at the end. Yeah, so be prepared to rationalize, be prepared to deal with the fractions.
When do you do the thing when you like multiply the number like 3/3? Like
Yeah.
To multiply that by like the number.
So we had said if you leave the number on the front instead of dividing everything by it,
Yeah.
that was the other method. So you could have done that here. You would have taken out a 3, and it would have been x squared plus 2x. And on the other side is just -5. So you don't divide the other side by the 3. Then you would do 2 divided by 2. That's 1 squared. It's 1. You add it here. You add it here, but that's when you have to multiply by the 3 first. Then I'd get 3x plus 1 squared equals -5 plus 3, which is -2. Then divide by 3. Then square root both sides. And you've got to separate it. Root 2 over root 3, rationalize it. And I'd get x equals, subtract the 1. So -1 plus and minus. This is root 6, so I root 6 over 3. So you get the same answer. It just depends on like which one you practice. Like which one do you feel the most comfortable with? Take it out, leave it on the front. So you're dealing with a whole number on the right-hand side until you go to add them. Or divide everything by that number and deal with the fractions from the beginning. It's up to you. So only if you take the number out and leave it here, you don't divide everything by it, do you then multiply it by the number you add inside the parentheses.
Can you do F?
From that same section?
Yes.
-3, yeah. All right, so bump the 3 to the other side. And then do you divide and keep it on the front, or do you divide everything? I can keep it on the front? Okay, so I'm going to take out a -5. X squared. The -5 also comes off of this, so plus 2x. Take the 2, divide it by 2, and square it. That's 1 squared. Add the 1 in here. Before I can add it over here, I have to multiply by this, which now makes it a -5. So I get -5, x plus 1 squared equals -2. Divide both sides by -5. X plus 1 squared equals 2/5. Square root both sides, putting a plus in the minus. Rationalize my denominator. And then subtract the 1. Let's see.
Could you put -5 plus or minus where it's in all of the 5?
You can. I'll take either answer. You just don't need to. Yeah.
Which one's easiest? The way we just did, or
It honestly depends. I would say if it's just a negative on the front, definitely divide everything by -1. So like that's way easier. Just get rid of it from the get-go. If it's got a fraction, like if when I divide everything by that number, I'm going to end up with a fraction on the other side, then it makes it a little bit harder. Because by doing it this way, you avoid the adding of the fraction here. You just have to divide by it at the end. So I would say I probably bounce back and forth between the two. If when I take this number out, if I divide everything by that number, it gives me a fraction over here, I tend to wait. I keep it on the front. But if it's like a negative where it's going to keep it a whole number and it just divides it evenly into it, I would do the negative from the beginning. Or if like this was divisible by 5, I would probably just divide everything by it. Yeah. So I would say avoid the fractions as long as you can, but you're not always going to be able to avoid them. Yeah. Other questions? Super confident, or you just don't even know what your questions are yet? Yeah. All right. This, like I said, the solutions are worked out here. When you come in tomorrow, it's not like we have a lot of time for review. So if you've got questions, feel free to stop by in the morning. I'll be in here. Okay, I'm also here after school today. But definitely make sure that you practice all those different types, okay? When I would say these, like if you wanted to practice a couple, using quadratic formula. You could practice the ones at the bottom also using quadratic formula just for the extra practice. The test instructions are going to say, unless, like it literally will say, solve by completing the square. I think there's two of those. Solve by completing the square. Or solve using quadratic formula. Solve using quadratic formula. Or it will say solve and you get to choose. So it's a blend of them. Okay? Solve by factoring is going to say. So you just want to make sure that you check it. If you're great at quadratic formula and you get all the way through your questions and you have time to check, feel free to go back and check them using quadratic formula. It doesn't matter. Okay? The only one you can't do every time is factoring. Everything else you can kind of go back and forth between. Yeah. Correct. It's the last big one. You'll have a couple homeworks, but that's it. Yeah. All right.